Welcome everyone. In this session, we're going to show you how easy it is to fine-tune LLMs using Kubeflow SDK and BuiltinTrainer. So the BuiltinTrainer is the capability of a trainer client, which allows you to fine-tune foundational models using the single line of command. And in this notebook, we're going to show you how you can fine-tune Qwen 2.5 with Alpaca dataset using the BuiltinTrainers. So the first step, like what we need to do, we just need to simply install the Kubeflow SDK in the notebook. So then I can use the list runtimes APIs to see available templates or runtimes. And in my cluster right now, I have two runtimes, which has a custom trainer and two runtimes for the built-in trainers. So the main differences in a custom trainer, you're fully responsible to define your training script. It could be a function, it could be multiple files, but in a built-in trainers, you can adjust the configuration. And on the right side, you can see the framework, which we're going to use for fine-tuning. So for this, we use the TorchTune, which provides a set of recipes we reuse for this fine-tuning. So to perform fine-tuning using these built-in trainer runtimes, it's a single line of command which you can run, and basically you're bypassing the name of the runtime in the train API. And this triggers the entire distributed training job, which performs the fine-tuning of the Llama 3.2. So just for the demo purposes, I'm going to simply run this job so we can see how easy it is to trigger the job using just a simple one line of command. And this will generate the random job ID. And we can also use the wait for job status API to wait until the job will be running. We can see the job steps. So similarly, because we first of all need to initialize the dataset, initialize the foundational models, and perform training, it has three different steps, which is dataset initialization, model initialization, and the training. So our train job controller is fully responsible to orchestrating all of those steps on the cluster. So you as a data scientist don't need really to be worried about these things. You can basically consume the results from the actual steps. For example, I can get the logs from my dataset initializer, which says the dataset is downloaded from the Hugging phase. Then the model also being downloaded from the Hugging phase, and then I can check the logs from my actual training. So here we can see some configurations which been generated by TorchTune. We didn't do any changes to this configuration, so we just use the default recipe that the TorchTune provide for Llama fine-tuning. And at the very end, we should see the training loop processes. So this is like very simple, extremely powerful, but it's extremely powerful because it allows you to actually experiment very quickly and iterate on the models you want to fine tune, or maybe you want to use your own custom data set, and you don't really want to adjust anything. You just want to use the default configuration that the runtime has, so you can quickly see the results of the fine tuning. So the next example, let's say maybe we want to adjust the configuration. Specifically, we're going to fine-tune here the Qwen 2.5 on 1.5 billion parameters. And to adjust configuration, it's very simple. We do have this built-in trainer class where you can specify the config. And inside config, there are a bunch of parameters you can adjust, like, for example, learning rates, or optimizers, so other parameters which TorchTune config gives you. But in this particular example, I want to say I just use 1,000 samples from the data set, and I want to use this number of resources for every node. So we're going to use 2 GPUs and 35 gigabyte of memory for every node. And I also want to use the LoRa fine-tuning. So I want to use the parameter efficient fine-tuning instead of fine-tune all of my parameters. I want to reduce number of parameters for fine-tuning to increase the to make it faster. And for this configuration, we're bypassing the LoRa rank equals 4 and the alpha equals 16. So similar to previous job, it will generate the random job ID. We can also list all of my jobs. So this is the job that we ran before. This is the currently running job. We can wait for job status until we'll be running. And then if I check the steps, similar to the previous example, we do have two initialization steps and one training step, which has 2 GPUs as we configured in the built-in trainer. So then once the training is running, we can also consume the logs. So here we can see the again torch tune configuration, which has the adjusted parameter for rank. And on the left side, because right now I'm running this notebook on the cloud, I'm sharing I- I'm basically sharing the volume between my notebook and the train job. And this is the torch tune configuration that you can also check and see the LoRa parameters we adjusted before we trigger the train job. So which is LoRa equals 4 and LoRa alpha equals 16. So once the training is complete, in the very end, we should see the fine-tuning results. So yes, so it says that the final epoch has been saved, and we also can see the artifacts in the epoch 0 folder. So this is our adapters artifacts, so we can reuse it. So here, like what we saw right now, extremely easy API. Like you can trigger the fine tuning with one line of command. You can adjust the configuration. It gives you like flexibility in a way that you don't really control the training loop. But at the same time, if you want to iterate quickly, if you want to have a way to maybe adjust one parameter, or maybe you have a common runtime that all of your teams of scientists want to reuse, it gives you like the Kubeflow SDK and the train job controller gives you an option to have a reusable templates for such configurations. So let's say also like what we want to show in this notebook, I want to take this adapter and I want to try to passing some random prompt to my model to say like, maybe I want to ask, can you explain what is Kubeflow Trainer? And here we're just loading the adapter from the local folder and we're trying to see the outputs from our foundational model. And as we can see, yes, the prompt has been generated here inside the notebook. So it's actually shows how easy it is to, after fine-tuning, do some evals or maybe adjust some configurations, which means like, because we have this capability of built-in trainers, like if you think that if after the evaluations you want to adjust something, you can go back to your train API and let's say I want to use maybe rank not 4 but maybe 8, and so with this, with the one line of change it will trigger another job which again will perform the fine tuning and you will get the results. uh, we believe this approach is very powerful because it gives you enough flexibility and configuration approach in a way how you can trigger those jobs, but at the same time if you want to have more control over training loop, you can always jump to the custom trainer or you have a way to configure the training function and the training loop. So if you want to learn more about built-in trainers and how you can use the Kubeflow SDK, please take a look in this website, in the Kubeflow website. We have an overview of built-in trainers. We can also have the overview of what is torch tune built-in trainers. You can find all the required information how to get started and how to try out example that I just showed to you on your cluster. In the same time, we're also working on dynamic built-in trainers because right now we only support TorchTune, but we eventually want to support other frameworks like TorchForge or Onslaught or Llama Factory, which gives us a way to for users to use other configurations to trigger those fine-tuning jobs. Thanks for watching.